Good evening. All right. So we were talking about work done by friction, in which we talked about work done by static friction and kinetic friction. We also have seen work done by kinetic friction is negative if the kinetic friction always dissipates energy. That's what you have seen. Ground is at rest. If this is pulled with a force F naught greater than limiting friction, so friction is F naught beats friction. Friction is Fk. So work done by friction on the block is F delta x cos theta Fk d cos 180, which is equal to minus FkD.
Yes, sir.
Sorry?
Yes, sir, and second, sir.
Okay, good. Okay, so let's look at the next question in the CPP, yesterday's CPP. Next question, Chudamu. A block of mass 5 kg is placed on a rough horizontal ground with a coefficient of friction 0.1. It is being pulled by a means of light horizontal rope with a constant speed 3 meters per second. Calculate the work done due to tension in the rope, the force of friction, and the normal reaction when the distance of 5 meters. Class. Yeah. So now what do we do? Yeah. So did you all read the question? So it's being pulled by a rope. I have to find out work done due to tension, work done due to normal reaction, work done due to friction effects, Fk. Now, why is it Fk? Because why is it kinetic friction? Because inside it's moving with some speed. There is relative motion between the block and the ground. Once there is relative motion, there is friction, which is kinetic friction. All right. So, and it's moving with constant speed, he said. That means net force on the block is zero. Net force on the block is zero means T is equal to Fk. That's what I can say. Because it's moving with constant velocity, net force on the block is zero. T is equal to Fk in magnitude. So work done by distance when moved a distance of 5 meters is work done by tension Wt is Fk 5 into cos 0. Wfk work done due to friction. Fk 5 cos 180 work done due to normal. Fwn mg 5 cos 90, which is equal to 0. So 5 Fk 5 minus 5 Fk 0. So work done due to normal is 0. Is that okay, students?
Sir, I don't understood, sir.
All right. He says, tension to pull చేస్తున్నారు, ఒక string pull చేస్తున్నారు block ని, which is moving with constant speed. I have to find out the work done because of tension, work done because of friction, work done because of normal reaction. So work done because of tension is F delta R cos angle between them. F displacement of force or point of application force and cos of angle between them. F is equal to Fk here. Why is it Fk? Because tension is equal to friction. Why is it so? The block is moving with constant velocity. There is no acceleration. That means net force on the block should be zero. I know Fk. T should also be equal to Fk, but in opposite direction. So Fk into 5 into cos of 0, because tension and displacement are in same direction. But whereas for friction, Fk into cos phi and displacement and friction are at an angle of 180 degrees. So cos 180. Normal reaction ఏమవుతుంది? Normal reaction is equal to mg into 5 into cos 90, because angle between the displacement and normal reaction is 90 degrees. So work done due to normal is 0. Work done due to friction is minus Fk, 5 Fk. Work done due to tension is positive 5 Fk. Net work done is 0. Note, net work done is 0. That means there is no energy being injected into the body. I told you, when there is work done, some energy is being injected into the body. All right, we'll talk about that in a while. Is it clear now, Bhavna? Likita, Shivani, Gayatri, Ashrita?
Yes, sir.
Yes, sir.
All right. Good. Now let's go for the next question. Next scenario. See, work done is dependent on displacement and force. Force does not depend on the reference frame, but displacement depends on the reference frame. That's why work depends on reference frame. So with respect to a reference frame, my work done will be different. For instance, this is a block on a block. And let's say some force F is applied here. If not, they are moving together, let's say. All right, force is not huge enough for them to slip on each other. They are moving together. All right. Now, with respect to ground, what is the work done by friction on the upper surface is what I have to find out. What is the direction of friction first? I have to find out. What is the direction of friction, students? On the upper block? I said they are moving together towards right with an acceleration A0. So effect is towards right.
Right.
So what is
Yes.
the direction?
Right, sir.
Sorry?
Right only, sir.
Towards right. All right. Why is it so? Because my effect is towards right. The only possible force on the upper block is friction. Friction has to be towards right. Right? Normal reaction is not contributing to the motion of the particle. And mg is also not contributing. So only friction is contributing. And friction is supposed to be in the direction of the effect. Cause is in the direction of the effect. Or effect is in the direction of cause. So friction is towards right with respect to ground if it moves a distance of delta x. So friction would be, work done would be friction, some friction F into delta x into cos 0. So work done by friction is zero, positive here and non-zero. It is static friction, but still the work done is non-zero. Kinetic friction వల్ల నెగటివ్ ఉంటుంది. Alright, negative ఉంటుంది. There's always loss of energy on one block. But on the because of static friction, it's turning out to be positive. Now look at this. With respect to this surface, pseudo force acts on it towards left, which is m into a naught. Friction is acting towards right. It has a tendency to slip towards left, so friction acts towards right. Now, with respect to this surface, there is no displacement at all. So work done in that accelerated reference frame is 0. Why is it 0? Because F into 0 into cos 0, cos 180. Angle between them is 180. Sorry, angle between them is 0. But F into 0 into cos 0. So if y is delta x 0, with respect to this surface, this particle is not moving. So this point of application of force is not moving. Work is done only when the point of application of force moves. When the point of application of force moves, then the work is done, and that work done is given by F into point displacement of the point of application of force into angle between the cos of angle between them. Here displacement is 0, that's why work done is 0. So it depends on reference frame. Okay, now look at the next question. Good one. Next one is a good one. When a body is being displaced under the action of force, and we are observing this from a non-inertial frame, then to calculate, sorry. What is it? A block of mass 5 kg is placed on a smooth horizontal surface, and a force of F is equal to 25 Newton starts acting on it parallel to the surface of the plane. Do you all see the question? Do you all read it? చదివారా క్వశ్చన్ చూస్తున్నారా? దొరికిందా క్వశ్చన్? దొరికిందా? మళ్ళీ పంపించాలా? షుడ్ ఐ సెండ్ ఇట్ అగైన్? స్టూడెంట్స్ कुछ तो
Yes,
बोलो यार.
sir, మళ్ళీ పంపియండి.
ఓకే. పంపిస్తున్నాను. పంపించాను. ఓకే. ఇప్పుడు చూడండి. క్వశ్చన్ ఇస్ seventh pick. Two blocks of masses m1 and m2 are placed on one above the other. There is no friction between the lower block and ground. The lower block is being pushed by a constant horizontal force F as shown in the figure. There is sufficient friction between the blocks so that they do not slip over each other. Draw the free body diagram of the upper block with respect to the ground and with respect to the frame attached to the lower block. Find the work done by various forces on the upper block in the two frames as the arrangement moves through a distance L. Try chestara.
Yes, sir.
So same situation, Fine, it's being pushed like this. Same thing as pulled. All right, but because he has to push, I'll push it as like this. It's the same thing. FBD draw cheyali. Work done because of each force కనుక్కోవాలి. First friction చెప్పండి నాకు. Friction on upper block and lower block. This is frictionless. Friction coefficient over here is, let's say, mu.
Lower block की left side ఉంటుంది sir friction.
Lower block is the left side. Okay, upper block is the right side.
Yes sir.
Why is it so?
సో ఎందుకంటే మోషన్ మనకి ఎఫెక్ట్ అట్టే ఉంది కదా సార్ రైట్ సైడ్.
Sorry?
ఎఫెక్ట్ రైట్ సైడ్ ఉంది కదా సార్ అప్పర్ బ్లాక్ కి అలా.
Yes. Others, is it okay? Why is it towards right? Why is the friction towards right? So let's draw the FBD. With respect to ground, let's draw the FBD of both the blocks. Okay. Friction is towards right. Static friction. Normal direction is upward. It has moved a distance of L or L naught. Mg is downward. MAD shows acceleration towards right. That's the FBD. All right, with respect to ground. Now with respect to accelerated reference frame, FBD మారిపోతుంది, MED కూడా మారిపోతుంది. You'll have all the real forces as it is, normal reaction, friction, mg, pseudo force towards left, ma0, and acceleration is 0 because the particle is not moving on the surface of the block. So MAD shows 0 acceleration, mass is m. FBD shows all the forces, 3 real forces and 1 pseudo force. 3 real forces are same as ground frame. As from the ground frame, we have an additional pseudo force over here, which is acting opposite to the direction of acceleration of the reference frame. The reference frame acceleration is towards right, pseudo force is towards left. All right, now let's say the work done. Work done from ground frame is F into L naught into cos of 0. Displacement is towards right, friction is towards right, angle between them is 0. So work done by force, friction force is positive. So friction force is injecting some energy into the body. Normal reaction, now N into L naught into cos of 90. mg valla, mg into L naught into cos of 90. ఇక్కడ ఏమవుతుంది, displacement is 0, you have all the forces, but displacement because of each force is 0. What is the displacement for work done because of pseudo force? Sorry, friction here, F into 0 into cos 0. Because of pseudo force, ma into 0 into cos 180. Normal reaction valla n into 0 into cos 90, mg into 0 into cos 90. Is it okay?
Sir, can you repeat again?
Sorry?
Sir, can you repeat it?
Yeah, all right. See, nothing. From ground frame and reference frame, I'm just talking, drawn the FBD and I find out the work done. Work done amount on the force and displacement are in the same direction. So friction into L naught into cos of 0 is the work done because of friction. Work done because of normal reaction. Normal reaction into L naught into cos of 90. This is all from ground frame. Work done by mg. mg into L naught into cos of 90. Is it okay now? So
Yes, sir.
it is 0 అయిపోతుంది, 2 0 అయిపోతాయి. Normal reaction and mg becomes 0.
Yes, sir.
Is equal to work done due to mg equal to 0. Work done because of friction is positive. All right, F into L is the answer.
Sir, రెండు
But
జీరో
work done because of friction on this accelerated reference frame, ఇక్కడ నిలబడితే this is accelerating, right? So we'll have a pseudo force towards left. 3 real forces will be as it is plus a pseudo force.
సార్
Yes.
జీరో ఎందుకు అయ్యాయి సార్ రెండు?
Sorry,
ఐ మీన్ రెండు జీరో ఎందుకు అయ్యాయి సార్?
cos 90 కదా.
కాస్ 90
Cos
వాల్యూ
90.
యా సార్, ఐ కాస్ జీరో. ఓకే సార్.
All right, cos 90. And see, whenever displacement is perpendicular to the force, work done is 0. ठीक है ना?
ఓకే సార్.
Okay. Okay, now let's talk about a work done due to variable force. ఇప్పుడు వరకు కాన్స్టెంట్ ఫోర్స్ గురించి మాట్లాడాము. నౌ లెట్స్ ఫైండ్ అవుట్ బికాజ్ ఆఫ్ వేరియబుల్ ఫోర్స్. వేరియబుల్ ఫోర్స్ వల్ల ఏమవుతుందంటే ఐ విల్ టేక్ ఎ స్మాల్ డిస్ప్లేస్మెంట్ dr bar. All right, a particle is being displaced from here to here, delta r bar or dr bar, under the action of this force F, which is also varying from here to here. All right, so this is theta 1, theta 2, let's say that doesn't matter, theta 1, theta 2. Now dr bar can be written as dx I cap plus dy j cap plus dz k cap. F can be written as fx I cap plus fy j cap plus fz k cap. F dot dr bar, integrating it from position 1 to position 2. This is my work done. Now, which is equal to integral fx I cap plus fy j cap plus fz k cap dot dx I cap plus dy j cap plus dz k cap. Dot product of two vectors ఎలా చేస్తాను? I'll multiply the corresponding coefficients of I, j and k and add them up. This
Yes.
is from position 1 to position 2. So that would be fx dx x1 to x2
plus fy dy
good. Go ahead.
FZ.
fz dz.
Z1 to Z2. Now this is my total work done.
Yes, sir.
Now let's look at the next question. A force of F is equal to 5 plus 2x plus 3x square acts on a particle in x direction where F is in Newton and x is in meter. Find the work done by this force during a displacement of, displacement from x is equal to 1 meter to x is equal to 2 meters. So fy and dy are 0. Only fx is there. Integral fx dx from x1 to x2 I do. So which is equal to 2 plus 3x square. What is the function? Variation in temperature 5 plus 2x plus 3x square. 5 plus 2x plus 3x square into dx, integrating it from where to where? 1 to 4. Is it okay? Is it correct? 1 to 2.
Yes, sir.
So what is integral 5 dx?
0, sir.
Not derivative.
5x, sir.
5x. What is integral 2x?
4x square by 2, sir.
2x. So integral 2x.
Two x square by 2.
Correct. So 2 get cancelled, I'll get x square. This one, 3x square, integral 3x square.
3x cubed by 3.
3 get
cubed,
cancelled,
sir.
x cube. So 1 to 2. Now that would be a substitute 2 first. So 10 plus 4 plus 8 minus 1. I substitute 1. 5 plus 1 plus 1. How much is this? 12, 22. Minus 6, which is equal to,
Sir, 7, sir.
-7.
yeah, 7. Sorry. That's what I go wrong. You have to be alert. What is 22 minus 7?
15, sir.
Sir.
15, no? So 15 joules is the work done. Let me check the answer. Yeah, 15 joules. All right, I'll give you another function now. As I told you, you'll have very basic 5 or 6 types of functions. One is quadratic, linear, quadratic, trigonometric, exponential. Now look at the next question. You have got an exponential function, a e power minus bx. How do you do the next one? Nothing, simple integration. We are just doing math. All right, we have still not entered into physics part of it. So f is equal to a e power minus bx, right? I integrate f dx from where to where? What are the values of x going from? From origin to distance d. So that is goes from 0 to d.
0 to d.
Look at the students. I plot f first. I get this function. This is a, and this is 1 by b. If you remember, this is a length constant which is given by 1 by b. All right, 1 by coefficient of x there. All right, that we have derived it one day, but if at all you have forgotten, we'll do it later. So now look at this. My position, my displacement is from 0 to d, and force is positive in that time. When it goes from 0 to d, my force is positive, so angle between them is 0. So f dx cos 0. So I integrate this now. A e power minus bx integral dx 0 to d. What is it? A comes out. Zero to d. What is integral e power minus bx? What is integral a power minus bx? Yeah, it's just a formula. Okay, I'll tell you. Not a problem. It is e power minus bx by minus b. See, integral e power kx. Integral is e power kx by k. Because if I differentiate this, I will get this. So if I integrate this, I'll get this. E power minus bx by b under limit 0 to d. I have got negative, so I'll invert the limit 0 d to 0. Now I'll substitute a by b into 1 minus e power minus bd.
Sir, can you repeat once again?
In Bhavna?
Sir, can you repeat once again?
Yeah, sure. See, ఫోర్స్ ఇలా వేరీ అవుతుంది, ఎక్స్పోనెన్షియల్లీ డ్రాప్ అవుతుంది. ఫోర్స్ ఇలా ఉంది, నా డిస్ప్లేస్మెంట్ తీసుకొని 0 టు d. అప్పుడు ఫోర్స్ ని fdx చేస్తాను 0 టు d. ఏ కాన్స్టెంట్ ఉంది, ఏ బయటకు వచ్చేస్తుంది, ఇంటిగ్రల్ బయటకి. ఇంటిగ్రల్ e పవర్ మైనస్ bx e పవర్ మైనస్ bx బై మైనస్ b. ఆ నెగిటివ్ సైన్ తీసేసి లిమిట్స్ ని ఇన్వర్ట్ చేస్తాను. 0 టు d ఉంది కదా, ఇప్పుడు d టు 0 చేసేస్తాను. నేను సబ్స్టిట్యూట్ ద లిమిట్స్. a బై b e పవర్ మైనస్ bx x ప్లేస్ లో 0 ముందు పెడతాను. e పవర్ 0 ఇస్ 1. Then I'll substitute d minus e power minus b into d. So I'll take a by b is common, 1 minus e power minus bd. Is the work done?
Yes, sir.
Acha, tell me, is the work done positive or negative? ఈ ఈక్వేషన్ చూసి చెప్పండి. 1 minus something less than 1. e power minus x is less than 1, right?
Yes, sir.
Positive
So
ఉంది
1
sir.
minus something less than 1 is positive.
Yes, sir.
All right, now let's look at the graphical interpretation of it. See, when I write integral f dx, what does this definite integral mean? Always definite integral means area under the fx graph, right? So area and if given fx graph, I can tell you what is the work done. So given a work, given area under the or fx graph, if I just find out the area under the fx graph, I can tell you what is the work done between the two limits x1 and x2. So I don't have to integrate everything. All I have to do is just find the area under the graph. So this is equal to ఇలా ఉంటే between x1 and x2.
Sir,
All right. Now, yeah.
మీరు స్టార్టింగ్ ఇంటిగ్రల్ పార్ట్ ఇంకా డిఫరెన్షియేషన్ ఎవరు చెప్పారో చెప్పాలి సార్, మీరా లేకపోతే కెవిన్ సారా లేకపోతే గురువిందర్ సారా?
Sorry, I didn't get you. What did you say?
ఇంటిగ్రేషన్ కాన్సెప్ట్ ఇంకా డిఫరెన్షియేషన్ కాన్సెప్ట్ మీరు చెప్పారా లేకపోతే గురువిందర్ సారా కెవిన్ సారా?
మ్యాథ్స్ లో గురిందర్ సరే చెప్తారు క్యాల్కులస్ లో, బట్ ఫిజిక్స్ లో వచ్చింది వీ హావ్ కవర్డ్ ఇట్ ఇన్ బేసిక్ మ్యాథ్.
ఓకే సార్.
ఆల్రైట్, యూ హావెంట్ అటెండ్ ద రికార్డెడ్ సెషన్స్ టిల్ నౌ.
సార్ నాకు అది నేను డిఫరెన్షియేషన్ వెతుకుతున్నా కానీ వేరే వేరే టాపిక్స్ దొరుకుతున్నా, ఇంటిగ్రేషన్ పార్ట్ చూద్దామన్నా.
ఇంటిగ్రేషన్ పార్ట్
అది ఆ వీడియో దొరకట్లేదు సార్.
ఓ ఓకే, లెట్ మీ చెక్. ఇఫ్ ఐ గెట్ ఇట్ ఐ విల్ ఫార్వర్డ్ టు యూ.
ఓకే సార్.
ఆల్రైట్, సో యాజ్ ఆఫ్ నౌ మనం ఇంటిగ్రేషన్ చేసింది ఏం లేదు. We are just applying the formula, basic formula. Those derivations of formula and all will be done in calculus. Alright, so ఇక్కడ this is okay. ఇది ఎలా వచ్చింది కూడా చెప్తాను, అదర్వైజ్ we have got time. f into dx, ఒక చిన్న డెల్టా x తీసుకున్నాను అనుకో, ఇక్కడ డెల్టా x, this area is what? Height is f, width is delta x. So f delta x is my area. Sigma, if I చేస్తే, if I sum up all these, I'll get area under the graph.
Yes,
But
sir.
because delta x is not, its delta x is finite, very small but finite. దీన్ని infinitesimal చేసేస్తే, dx చేసేస్తే, this sigma will turn into sigma as s, elongated s, summation from x1 to x2. That's what we get integration లో. బట్ ఇంటిగ్రేషన్ కి ఇంటిగ్రల్ fx dx కి ఫార్ములాస్ ఉంటాయి. ఇంటిగ్రల్ x dx కి x² 2 ఉంది, ఇంటిగ్రల్ e power x కి e power x ఉంది, ఇంటిగ్రల్ sin x కి minus cos x ఉంది. So those formulas will be derived in calculus. But we are going to apply simply, we know the formula, we accept the formula as it is and go and apply the formula in the physics part, in the physics classes. Alright, కానీ ఏరియా అనేది గ్రాఫ్ ఇలా వచ్చింది. చిన్న డెల్టా ఎక్స్ తీసుకుంటాను, దాన్ని రెక్టాంగిల్ ఏరియా కనుక్కుంటాను. ఐ మేక్ డెల్టా ఎక్స్ టెన్ టు 0. So limit delta x tends to 0, sigma tends to integral. All right. Okay, now look at the next one. A force F acting on a particle varies with the position x as shown in the figure. Last second pick. Now you have to understand this carefully. Graph ఇచ్చారు, a coordinates ఇచ్చారు, -2, +2, -10, +10. See, again, there is a lot to interpret in this graph, but we'll interpret as we go ahead in the syllabus. All right, but we'll just talk about the mathematical aspect of it now, just the graphical aspect of it. We'll do the physical analysis later. Actually, what is happening here is a particle is taken from -2 to 0 first. All right. What's the
Yes,
question? Have you seen the question? Find the work done by the force in displacing the particle from -2 to 0, 0 to 2. All right. Now -2 to 0 తీసుకెళ్ళినప్పుడు my displacement is towards right. Right.
Yes, sir.
Displacement is positive, but force is negative. Force negative కదా, below x axis ఉంది కదా force, -10, -9, -8 అలా ఉంది. So work done will be negative, and that will be equal to negative of area of this one, half times base into, or height into base, that is 10 joules, -10 joules. When it goes from 0 to 2, my displacement is positive, my force is also in the towards right,
Towards
Yes.
right.
positive. So angle between them is 0, work done will be positive. So half
10.
times
10
10
joules.
times 2, again 10 joules, positive 10 joules.
Yes,
If I say
sir.
what's the work done from -2 to 2?
0.
0,
Zero,
because
zero.
area under the graph is 0.
sir.
0 వస్తుంది. ఇలా
Yes,
చేస్తే కూడా
sir.
0 వస్తుంది, area under the graph is 0. ఇది నెగటివ్
Yes,
ఏరియా, అది పాజిటివ్ ఏరియా, ఏరియా అండర్ ద గ్రాఫ్ ఇస్ 0.
Yes, sir.
All right. Okay, let's go for the next one now. కానీ ఇక్కడ చూడండి, if I leave a particle here, if I release a particle here, it will go towards left. If I release a particle here, it will go towards right. If I release a particle at origin, it will stay there. That's an equilibrium point. What kind of equilibrium? The moment I say equilibrium, you should ask me, sir, what kind of equilibrium? So what kind of equilibrium is it? It's unstable equilibrium. కొంచెం డిస్ప్లేస్ చేస్తే it is going away from equilibrium. ఇట్ సైడ్ డిస్ప్లేస్ చేస్తే లెఫ్ట్కి వెళ్ళిపోతుంది, అటు సైడ్ డిస్ప్లేస్ చేస్తే రైట్కి వెళ్ళిపోతుంది. So that's unstable equilibrium. So if I leave a particle here, it will go towards left. But I'm taking a particle from -2 to 0. So I'm pulling the particle. See, against the force is towards left. I'm pulling the particle towards right. So I'll have to apply some force to pull it towards right. ఇక్కడ నుంచి ఇక్కడ తీసుకెళ్లేటప్పుడు force is towards right. I don't have to apply any force. I can just leave the particle that will go on its own. But if I have to bring it from 2 to 0 తెచ్చుకోవాలంటే అప్పుడు work done ఎలా ఉంటుంది? Displacement negative ఉంది, force positive ఉంది, work done by the force will be negative.
Yes, sir.
Okay, let's go for the next one now.
When it will become stable?
Sorry,
When it will become stable, sir?
stable equilibrium. Okay, that's a good question. గ్రాఫ్ ఇలా ఉందనుకోండి, ఇది ఈక్విలిబ్రియం పొజిషన్ బికాస్ ఇట్స్ కటింగ్ ది ఎక్స్ యాక్సిస్ ఓవర్ హియర్, ఫోర్స్ ఇస్ 0. కానీ కొంచెం డిస్ప్లేస్ చేస్తే ఫోర్స్ ఇస్ టువర్డ్స్ లెఫ్ట్, అది వెనక వచ్చేస్తుంది. ఇక్కడ డిస్ప్లేస్ చేస్తే ఫోర్స్ ఇస్ టువర్డ్స్ రైట్, అది టువర్డ్స్ రైట్ వెళ్ళిపోతుంది, వెనక వచ్చేస్తుంది మళ్ళీ. సో దట్స్ స్టేబుల్ ఈక్విలిబ్రియం. ఎలా గుర్తుపెట్టుకోవాలంటే, ఒక బౌల్ తీసుకొని ఒక బాల్ ఇక్కడ పెడతాను, అక్కడే ఉంటుంది. కొంచెం డిస్ప్లేస్ చేస్తే ఇలా ఆసిలేట్ అవుతుంది. సో స్టేబుల్ ఈక్విలిబ్రియం. ఒక బౌల్ ఇలా ఉంది, దానిపైన పెడతాను, ఎగ్జాక్ట్లీ పైన పెడతాను, దట్ విల్ స్టే దేర్. కొంచెం డిస్ప్లేస్ చేస్తే టువర్డ్స్ రైట్ వెళ్ళిపోతుంది, టువర్డ్స్ లెఫ్ట్ వెళ్ళిపోతుంది. అదే ఇంకొక బాల్ ఉంది ఆన్ ఫ్లాట్ సర్ఫేస్, ఐ డిస్ప్లేస్ ద బాల్, ఇట్ విల్ స్టే దేర్ ఓన్లీ. సో దట్స్ న్యూట్రల్ ఈక్విలిబ్రియం. స్టేబుల్, అన్స్టేబుల్, న్యూట్రల్. దేర్ ఆర్ 3 kinds of equilibrium always. సో ఇది అన్స్టేబుల్, ఇది స్టేబుల్. న్యూట్రల్ ఇస్ ఫోర్స్ 0 ఉన్నప్పుడు న్యూట్రల్ ఉంటుంది. ఇలా ఉంది అనుకోండి, దిస్ ఇస్ న్యూట్రల్ ఈక్విలిబ్రియం, దిస్ పార్ట్ ఇస్ న్యూట్రల్ ఈక్విలిబ్రియం.
Yes, sir. Thank you.
Okay. Look at the next graph now. F is equal to, how much is it? F0 into x by x0 minus 1. Can you plot that graph? F0 into x by x0 minus 1. This is my force. And the question says, calculate the work done moving the object from 0 to 3x0 by plotting fx graph, and then calculate the area under the graph. Also calculate the work done by evaluating the line integral. So మనం ఇంటిగ్రేట్ చేసిన డైరెక్ట్ ఏరియా అండర్ ద గ్రాఫ్ క్యాలిక్యులేట్ చేసిన ట్రయాంగిల్, ట్రెపీజియం, రెక్టాంగిల్ యూస్ చేసి నాకు సేమ్ రావాలి. సో లెట్స్ ప్లాట్ ద గ్రాఫ్ ఫస్ట్, లేకపోతే మనం ఇంటిగ్రేట్ చేసుకుందాం. f is equal to f0 into x by x0 minus 1 dx. I integrate from 0 to 3x0. f0 is constant, comes out x by x0 minus 1 dx from 0 to 3x0. దీన్ని ఇంటిగ్రేట్ చేయండి. వాట్ ఇస్ ఇంటిగ్రల్ x dx?
Sir, x square by 2.
x square by 2. Integral 1
X, sir.
అంతే, 0 to 3x0. ఇది సబ్స్టిట్యూట్ చేసి చెప్తారా వాట్ ఇస్ ద ఫైనల్ ఆన్సర్?
Yes,
Because if
sir.
I substitute, I'll do something wrong again. నేను ఏదో తప్పు చేసి వదిలేస్తాను. 9x0 square by 2, 9x0 by 2. Check if this is correct. I'll also check the answer till then.
Yes, sir, it's correct.
It's correct. What did I do? I just substitute the upper limit minus lower limit. Upper limit substitute చేస్తాను, x square, 9x0 square by 2x0. x0 get cancelled, 9x0 by 2 minus 3x0. LCM తీసుకున్నాను, 2 into 3 is 6, 9x0 minus 6x0 by 2. That is 3x0 f0 by 2. So that's the work done. నాకు లైన్ ఇంటిగ్రల్ తో వచ్చింది. బట్ లుక్ ఎట్ ద గ్రాఫ్ నౌ. గ్రాఫ్ చూస్తే గ్రాఫ్ ప్లాట్ చేయాలి ముందు. గ్రాఫ్ ఎలా ప్లాట్ చేస్తారు? ఇట్స్ సింపుల్. y is equal to mx plus c గ్రాఫ్ ఉంది. సో x ఇంటర్సెప్ట్ y ఇంటర్సెప్ట్ ప్లాట్ చేస్తే వచ్చేస్తుంది. సో x ఇంటర్సెప్ట్ ఎంత ఉంది, y ఇంటర్సెప్ట్ ఎంత ఉంది ముందు చూడండి. x is equal to 0 పెడితే మైనస్ f0 ఉంది,
Yes, sir.
రైట్. x ఇంటర్సెప్ట్ ఎంత ఉంది, f is equal to 0 పెట్టినప్పుడు x0 ఉంది. All right. Now particle is taken from 0 to 3, 3x0. Is it 0 to x0, 2x0, 3x0? ఇప్పుడు చూడండి, I can either calculate this minus this. Lower area is negative, upper area is positive. దీన్ని యాడ్ చేసి దీన్ని సబ్ట్రాక్ట్ చేస్తే వచ్చేస్తుంది. Or by symmetry of the triangles, this area equal to this area. So ఇక్కడ వరకు 0. So 2x0 to 3x0 ట్రెపెజియం ఉంటుంది. ఆ ట్రెపెజియం ని క్యాలిక్యులేట్ చేస్తే అయిపోతుంది. Now let's find the area of the trapezium there. ఇది 2x0 అంటే what is the coordinate here? ఆ కోఆర్డినేట్స్ తెలుసుకోవాలి కదా ముందు. Substitute this 2x0 here, f0. When I substitute 3x0 here, 2f0. So this is f0, this is 2f0. ఎలా వచ్చింది? I substitute x value, 2x0 over in this equation, 2x0 by x0, x0 is cancelled, 2 minus 1 is 1, f0. 3x0, 3x0 by x0, x0 is cancelled, 3x0 by 3 minus 1, 2, 2f0 is the value here. What is the area of a trapezium? Sum of the sides into distance between them, half of that, which is 3x0 f0 by 2. అంతే, వర్క్ డన్. సేమ్ వచ్చింది చూడండి.
Yes, sir.
So depends. If at all you are quick in integration, do it. If you are quick in finding out the area of trapezium, plotting the graph, do this. But sometimes ఇలా ఇచ్చారు అనుకోండి, మాడ్యులస్ ఇచ్చారు, ఆర్ ఫంక్షన్ ఇస్ లైక్ దిస్. I have to find out from here to here. అప్పుడు ఎలా కనిపిస్తుంది? If I cannot write these equations and then integrate, that will take time. So area of a triangle, area of a trapezium చేసుకోవాలి.
Okay,
All
sir.
right. Now let's understand spring force. Spring force మనం మాట్లాడాము, బట్ వర్క్ డన్ బికాస్ ఆఫ్ స్ప్రింగ్ ఫోర్స్ మాట్లాడలేదు. Is equilibrium position. I displace it by x. Force will be towards left, kx. Right. So I'll have integral minus kx dx from x1 to x2 is my work done, which is equal to, how to integrate this? Integration, tell me. Minus kx square by 2 under limits x1 to x2, which is equal to minus k by 2 into x2 square minus x1 square.
Yes, sir.
This is my work done. Or if I remove this minus sign, I'll have x1 square minus x2 square. Now look at the students. This is my formula for spring force key. Spring force wala work done. But let's understand physically. ఇప్పుడు చూడండి, ఇది x1 అనుకుందాం, ఇది x2 అనుకుందాం, x2 ఇక్కడ వరకు అనుకుందాం. When particle is coming from x1 to x2, but here is going from x1 to x2, right? Yeah. x1 to x2 వెళ్ళినప్పుడు what is the force? What is happening to the force here? Force is towards left. Displacement is towards left. Work done should be
Positive, sir.
positive. Formula wise చూద్దాము. x1 is greater than x2. So x1 square is greater than x2 square. x1 square minus x2 square is greater than 0. Work is greater than 0.
Yes, sir.
All right. అదే ఇప్పుడు ఇక్కడ నుంచి ఇక్కడ వెళ్తుంది అనుకుందాము. ఈ వాల్యూ నుంచి x3 x1 నుంచి x2 వెళ్తుంది అనుకుందాము. అంటే ఈ వాల్యూ ఇప్పుడు ఈ x2 x1 కాదు. Now this x1 this x2. లెఫ్ట్ కి వెళ్తున్నప్పుడు కంప్రెస్ అయినప్పుడు ఫోర్స్ ఇస్ టువర్డ్స్ రైట్. డిస్ప్లేస్మెంట్ ఇస్ టువర్డ్స్ లెఫ్ట్. So what is the work done? Negative. Formula wise చూద్దాము. x1 square minus x2 square. x1 is less than x2. This is negative. x1 square is less than x2 square. This is negative. Work is less than 0. Now look at this. చూడండి, ఇప్పుడు నేను చెప్పాను కదా, work is nothing but injecting energy into the particle. Work done, ఇక్కడ ఏమవుతుంది, work is positive by the spring force అంటే when it's being pulled, what is happening to the kinetic energy of the particle? Increasing, right? Speed up అవుతుంది కదా, accelerate అవుతుంది. మనం న్యూటన్స్ లాస్ అప్లై చేసి ఏం చెప్పగలుగుతాము? Force is accelerating the particle, so acceleration is towards left. కొంచెం దూరం వెళ్ళాక it will speed up towards left. ఈక్విలిబ్రియం వచ్చాక, ఈక్విలిబ్రియం దాటాక ఏమవుతుంది? Force is towards right, velocity is towards left, it will decelerate, so it will retard. Retard అంటే kinetic energy is dropped. అందుకే వర్క్ డన్ నెగటివ్ వచ్చింది. వర్క్ డన్ నెగటివ్ అంటే కైనెటిక్ ఎనర్జీ ఈస్ బీయింగ్ సక్డ్ అవుట్ ఫ్రమ్ ద పార్టికల్. ఆల్రైట్, ఐఎమ్ జస్ట్ టాకింగ్ అబౌట్ కైనెటిక్ ఎనర్జీ రైట్ నౌ. ఆల్రైట్, we'll talk about whole of a total energy after talking about potential energy, but I'm just talking because kinetic energy you already know from school level, it's half mv square. Energy, because due to the virtue of its motion, is half mv square. So this work done, work by spring is injecting some energy, which is kinetic energy, into the block. Ikkada it's being leaked out. Work by the spring force is opposite, that's stopping the particle, retarding the particle in terms of Newton's laws. But if I say in terms of work and energy, energy is being leaked out. So where is this energy leaking from? Block. So where is the energy coming out from? From kinetic energy. So kinetic energy is being dropped and work done is being negative. All right. Okay. Now let us say I project a particle from here. V0 though. Sorry. ఇక్కడ వదిలేసాను, పార్టికల్ ని వదిలేసాను. వెలాసిటీ 0. నేను ఇక్కడ వెలాసిటీ ఎంత ఉంది కనుక్కోవాలి. నేను ఎలా ఆలోచిస్తాను? ఇక్కడ నుంచి ఇక్కడ వరకు వర్క్ డన్ ఇస్ పాజిటివ్. ఇస్ ఇట్ పాజిటివ్? డిస్ప్లేస్మెంట్ ఇస్ టువర్డ్స్ రైట్, ఫోర్స్ ఇస్ టువర్డ్స్ రైట్, వర్క్ డన్ ఇస్ పాజిటివ్. సిమెట్రికల్లీ వర్క్ డన్ ఇస్ నెగటివ్ హియర్ అండ్ ఆఫ్ ద సేమ్ మాగ్నిట్యూడ్, బికాస్ డిస్ప్లేస్మెంట్ సేమ్ ఉంటుంది, వర్క్ డన్ ఇస్ టువర్డ్స్ లెఫ్ట్. సో వర్క్ డన్, టోటల్ వర్క్ డన్ ఇస్ 0. If total work done is 0, no energy is being injected into the particle. That means energy ఎంత ఉందే అంతే ఉంటుంది. ఎనర్జీ ఎంత ఉండే, కైనెటిక్ ఎనర్జీ 0 ఉండే, కైనెటిక్ ఎనర్జీ 0 నే ఉంటుంది. సో నెట్ వర్క్ డన్, we can talk about change in kinetic energy basically. Kinetic energy ఎంత లోపల వచ్చింది, ఎంత బయట వచ్చింది, we can find out from the net work done. Net work done analyze చేస్తే, we are talking about the physics of the problem now. Net work done analyze చేస్తే, I can tell you what kind of change in kinetic energy is being observed. Observe the work done by the net force, you can talk about the change in kinetic energy of the particle. All right. So next class I want you to read something and come. Read work energy theorem and come. All right. Work kinetic energy theorem అని ఉంటుంది. I'll tell you the page numbers otherwise.
సార్ థీరం అంటే చేంజ్ ఇన్ కైనెటిక్ ఎనర్జీ ఇస్ వర్క్, ఆ థీరం సార్?
That's it.
ఓకే సార్.
I'll tell you the page number from Cengage. Read it. Page number 7.5, chapter 7, 5th page. All right, you just read that. We'll complicate a bit, కొంచెం situations in complicate చేసి we'll understand. ఓకే, కానీ ఇక్కడ ఇప్పుడు చూడండి, ఇక్కడ పార్టికల్ ని వదిలేసాను అయితే ఇక్కడ వెళ్ళింది పార్టికల్. అదే పార్టికల్ ఇక్కడ ఉంది అనుకోండి, x1 to x2 వస్తుంది. హౌ ఇస్ ఇట్ కమింగ్ ఫ్రమ్ x1 to x2? నాకు వెలాసిటీ ఉంటేనే x1 to x2 వస్తుంది. సో దేర్ సమ్ ఎనర్జీ at x1, at x2 the energy is lost. Where has that energy gone? Because of work it is being sucked out. And where has it gone? We'll talk about it later. But it is a work which is being transiting energy from the particle to the system or to something else. That something else we'll talk about later. But work is energy in transit. Energy transit లో ఉన్నప్పుడు దాన్ని work అంటాము. When energy in transition లో ఉంది, that time work is done. All right. So work is nothing but we say f dot dr, f dr cos theta, is mathematical aspect. But physically we say work is energy in transit. Energy in transit, work is energy in transit. All right, let's do one more problem and then let's end the session. So you quickly tell me what's the answer. I have a graph. -10, 10, 2, 4. I have to find out the work done from -4 to 4. Particle is taken from -4 to 4. I have to find out the total work done. And this FX graph. So how do you do it? Will I write equations and then integrate? Ala kuda cheyochu, but it's time taking. Alright. So what I'll do, I'll find area into the graph. Area into the graph చేసినప్పుడు, this is area 0. అయితే ఇక్కడ వరకు నేను calculate చేయను. I'll just calculate the area of this trapezium now. Area of the trapezium ఎంత ఉంది? 4 and 2. This length is 2, this length is 4. So 4 plus 2, sum of the sides, and distance between them is 10. Half of that, 5, 30. 30 joules is the work done. Is it correct? Just check. My math could be wrong.
Yes, sir, it is correct.
Yes, sir. It's correct.
All right. So have you understood the work done? Like how do I calculate the work done?
Yes, sir.
Okay, madam.
Yes,
మీరు
sir.
all right. All right. So మీరు ఆ book లో Engage book లో you just read the first five pages. కొన్ని examples కూడా ఉంటాయి. Examples చేయండి. All right. Further examples I'll make you do. Whenever the complicated examples వస్తే I'll make you do. But right now you just go through first 5 pages of the chapter. 7th chapter లో work energy theory, work energy and power. ఆ chapter లో first 5 pages చదవండి. All right. And within 2 days you will receive the DPP on previous topics. Till then we'll go ahead with work energy and work energy theorem. All right, students. That's all for today. We'll see you tomorrow again. Any doubts you have got? Any doubts? Yes or no?
No, sir.
Okay, Bhavna says no. Others?
No, sir.
Okay, Ashrita.
No, sir.
All right, all right. Okay, Gayatri. All right, then we'll end the session now. Bye, everyone. Good night and good luck.
Bye, sir.
Bye-bye.